This is problem number 4A from the sample test problems for test number 3. Solve each of the following optimization problems. From experience, a retailer knows that sales of Christina Aguilera CDs depend on the price charged for each CD. If the price is $20, 1,000 CDs will be sold in 1 week. For each $1 reduction in price, the number of CDs sold in the week will go up by 100. Find the price that should be charged to maximize the store's weekly revenues. Use calculus methods, not graphical ones. Okay, so first thing we're going to do is try to translate the function to be optimized. In this case, we're trying to maximize the store's revenue. So we'll write a formula for revenue here in English. And we should be able to figure out that revenue is equal to number of CDs sold times the cost that we charge per CD. Maybe instead of cost, price is a better word. Price per CD. So let's go ahead and give variable names to these letters or these concepts. So revenue we'll call R, number of CDs we will call X, and price per CD we will call P. I'm being very lazy and sloppy here. Should write something more formal like let X equal the number of CDs sold, etc. So that's the function to be maximized. The problem is the right-hand side has two variables in it, and we can only handle it when it has one. So our job is to come up with some relationship between X and P. And to be even more precise, we're looking for an equation that has X and P in it and no other letters. So what I'm going to do is make a table based on the data in the chart, I guess based on the data in the paragraph. So it says that if the price is $20, so that's a 20 there, then 1,000 CDs will be sold in a week. And then it says if you reduce the price by $1, so that brings us down to $19, then the number of CDs sold goes up by 100. So that brings us up to 1,100. I'll put one more data point in this table. If we go down by another $1, we gain another 100 CDs sold. And hopefully looking at the data in the table, you can convince yourself that there's going to be a linear equation that relates X and P. So our task is to come up with some equation, but instead of Y equals MX plus B, here we have a P equals MX plus B. So use the data in the table, pause the video right here, see if you can find the M and the B, and then unpause the video when you're done. Okay, so if we're back, hopefully we've had a chance to write down some equation that relates these two things. So I'll put dot, dot, dot. You did a bunch of work, and you got P is equal to negative 1 over 100x plus 30. And so we're going to take that equation and plug it in right here to replace P. So this revenue equation becomes X times, and then instead of P, all that stuff highlighted in yellow. Perfect. Now we have an equation with only one variable in the right-hand side, so we can do calculus things to maximize it. For example, we're going to want to take a derivative of it. Instead of using the product rule, I'm going to go ahead and distribute first. You're welcome to use the product rule, but I'll write it as negative 1 over 100 times x squared plus 30x. And now we can do all kinds of calculus things to this. So we'll take a derivative first. R prime equals. Negative 1 over 100 is a constant multiple. It stays, and in fact, it gets multiplied by the 2x that's going to come through. So it's a negative 1 over 100 times 2x plus derivative of 30x is 30. Let's put a line to separate these. So we're going to want to take this and set it equal to 0. Before we do, let's clean it up a little bit. So the 2 and the 100 cancel and make negative 1/50th x plus 30. And we're looking for the maximum here, maximum revenue. So we're going to set this derivative equal to 0 and then solve for x. So negative 1/50th x equals negative 30. Multiply both sides by negative 50, and we get x equals 1,500. 1,500 CDs. So x equals 1,500 CDs is the critical point, the critical number. Technically, you should do a little bit more work to verify that indeed x equals 1,500 gives you the maximum revenue, because a critical point could just as well give you a minimum value, or it could be neither a max nor a min. I'm not going to do that part on this video. but 1,500 turns out to maximize the profit. We'll go ahead and maximize the revenue, I should say. We'll go ahead and use the highlighted equation in yellow to find the corresponding price. So according to the yellow, it's negative 1 over 100x. We just figured out the best x is 1,500 plus 30. So that gives us 15, and P is the price, so that's $15. So what that means is that we should charge $15. We will sell 1,500 CDs, and those things together will give you the maximum possible revenue.